is now recording. All right, here we go. So exercise 3 is the opposite. You're now finding the sequence of transformations that take the graph from this is the original to the graph of y equals x squared. Okay, so doesn't always have to be the basic graph, doesn't have to be y equals x squared to this. It could be this to that as well. Okay, so you just need to know which one's your original x and then which one's your new x, new y. So here we go. Your goal is to figure out what goes inside those brackets in the mapping notation. What we know is, oh, I wrote it wrong. That's all right. We'll swap it around. I think I might have wrote it wrong. I think question 3b may have wanted you to go from this to that. Anyone got the textbook? Actually, I got the textbook. What am I doing? I'll check. It's correct? Question 3b. Okay, so I wrote it wrong. The notes are wrong. Can you guys just cross that off and then write here y equals to 3x plus 2 squared plus 5, because that's the original x, original y. And you're moving through a sequence to get down to y equals to x squared. I just like the layout to be in order so that you can do a comparison. Okay, so this is our new y. I'll put a dash there, and that's our new x. The top one is meant to be our original x, original y. So our goal is to figure out, well, what did you replace for original x to end up getting this? Okay, that's what you're trying to figure out. In this case here, actually, I chose a question that so happens to have saved you a lot of work, because all it is inside the brackets, as you can see, this here, what are you squaring? I'm squaring 3x plus 2. Let's have a look at the new equation. The new equation, what am I squaring? X dash. So if I were to work backwards, I'm literally saying x dash is equal to 3x plus 2. Usually it's not like that, and then you have to rearrange the equation so you get x dash, but it looks like you already got x dash by itself. So that saves you trouble, because that means this is your new x, remember? I already know what my new x is. It's just 3x plus 2. All right? And then let's see if this one requires some transformations here. So I need to go y dash. I need to get it back to original y. So you can see here, the original y, there's that extra plus 5. So I need to bring the plus 5 back. So here we have y minus 5 is equal to 3x plus 2 squared. And I've already got the x sorted. So the x's have been here. I figured that one out. But what I now need to compare is y, original y minus 5 is being replaced with y dash. You see what I'm doing there? I'm doing a comparison. So I look at this and I say, well, that's squared. What am I replacing in the square? I'm replacing with x dash. So that means x dash is equal to 3x plus 2. Here, I've just got a y value. There's no extra numbers on the side. So this y dash is replacing y minus 5. I can't leave that 5 there because they're not the same by comparison. So by moving the 5 across, these two are now the same. And therefore, I can say y dash is equal to y minus 5. And unfortunately, the question I happen to pick tells you what y dash is already. Usually from this step, you're meant to rearrange until you get x dash y dash, but it's already there. So y dash happens to equal to y minus 5. So we had to read the transformation, Dr. T. Remember, always dilation, reflection, translation, because they're asking for a sequence. And you read exactly what you see there. So what is the sequence? What should the sequence be? Let's zoom in a bit. Let's go. What's the first sequence? Can I please have, let's go Serena. What are you seeing? It is, that's true, but make sure to do Dr. T, so in that order. So the translation, yes, it is 5 units down. I'm just going to write it here. Translation 5 down. Which one comes first? Dilation. What is this dilation, Samuel?
There's a dilation of 3
Yes, that is correct. So dilation of factor, make sure to put in the word factor, 3 from y-axis. Very good. And then the last one, obviously, it is translation of 2 units right. Because translation is addition, it actually doesn't matter which one goes first. You could have said translation 5 down and then translation 2 units right. Doesn't matter, but the dilation needs to come first. Okay, because you're timesing the x by 3, and then I like to follow up with +2 before I go to the y. Okay, so this one was relatively easy because the answer happened to be the transformation as itself. But if you flip to the next one, hopefully I picked one where... Yes, okay, this one will add in a bit more of a complexity. Okay, let's do this one together. I was going to get you to do it, but I feel like because the first one was a dud, I'll do this one with you. All right, let's have a look. Let's have a look. This is the last example for today, exercise 3E, question 3E. You are transforming y equals 2 root 4 minus x plus 3 to y equals to negative root x plus 6. This is your original function. This is your new function. So I usually like to put a dash on it just to help me remember which one's new and which one's old. Okay, so what's the goal? I like to start off with the x's because that's within the function. Now the function is a square root function, so that means this 4 minus x is what I'm square rooting. That's what affects the x. It's not the plus 3, it's not the times 2. So I then go look at my new function. What am I square rooting? I'm square rooting the new x. So what's nice is from this step already, I can say new x is equal to 4 minus x. Can you see that? I'm going to highlight it so I'll color code it. What am I having troubles with? It's that y. How did I end up with a y dash here and a plus 6 there? Well, and that negative there, everything that is not highlighted in yellow belongs to the y. So I'm going to rearrange all of them to be in the y section. I'm going to rearrange all this to be in the y section to compare. So what I'm going to do here is, let's rearrange this equation. This gives me y minus 3 on 2, because I'll subtract 3 on both sides, and then divide both sides by 2. Whilst this one should be y dash minus 6 on both sides, and a negative on the outside. Root x dash. Hopefully I'm not confusing you there. So here I've got root 4 minus x. Can you see what I'm doing? So this, I've just rearranged it so I've got all the y's on one side. Square root is still there, and that is everything to do with the x. Whilst over here I did the same. I moved all the numbers, negatives, and the plus 6 so that this is all the y transformation. And here I've got root of x. So that way you can compare and say 4 minus x deals with the x there, whilst in blue, y minus 3, so original y minus 3 divided by 2 is equivalent to negative of y dash minus 6. These two are linked, whilst these two are linked. Nothing to do with the function. We're only interested in the x and the y coordinates. So here, if I match them, that's how I got x dash minus 4 equals to 4 minus x, whilst this one should be, and this is the big one, I'm going to write in, y minus 3 divided by 2 should equal to negative of y dash minus 6. See what I'm doing there? Questions? Sometimes when we're doing this and there's a bit more complications, students get confused what I'm doing. So I'm just comparing x's with x's, y transformation with y transformation. What's the goal? The goal is to figure out what is the x dash and y dash equal to. Because at the end of the day, you want to read this. You need an x dash equals something and y dash equals something. What's beautiful, this is already done for you. You don't have to do anything. X dash equals to 4 minus x, so x dash equals 4 minus x, or you can rewrite it as negative x plus 4. That's my transformation for the x. For the y, you have to rearrange all of that. So here we go. let's rearrange this. Y. So I'm going to zoom in just so you can see. To get y dash by itself, get rid of a negative, divide both sides by negative. So here we go. I've got now negative of y minus 3 on 2 is equal to y dash minus 6. To get y dash, I need to get rid of that minus 6. So add 6 on both sides. So now I get negative of y minus 3 on 2 plus 6 equals y dash. This is my transformation for y. Obviously, you can expand the brackets and simplify. So I'm just going to move it over here. Let's move over this over here. So y dash is equal to negative of y plus 3, minus 3, over 2 plus 6. Now, if you expand the brackets, that's negative of y minus 3 on the top, divided by 2, plus 6. If you like even further, you can rewrite the 6 as a fraction. So it'll be negative y plus 3 plus 12 all over 2. Have I gone too fast? So 6 over 1, 12 over 2, same thing, so I'm combining them together. I've expanded the brackets, negative times y, negative times negative 3 is plus 3 plus 12. Yep. Oh, how did I get that 12? Thank you. It is 2 on the bottom. So 12 on 2. And then negative y plus 15 on 2. And if you want to read the transformation, you can split it up. That's the same thing as saying negative of half y plus 15 on 2. See what I'm doing there? Now, this is a sequence of transformation, and depending on the back, the answer to the back may have stuck to this. If they stuck to this, then you would have read it as move down by 3, dilation of factor half, then reflection, and then translation. That would be, I think that's how the back might have wrote the answers. But if you simplify it, this will be different now. This will follow Dr. T. It will be dilation of factor half, reflection, then translation. But regardless, if you type this equation into the new equation and you type this one, they both have the same graph. It's just the sequence is different. Okay? So in the exam, I normally tell my students to not simplify and stick to this. Usually, I know in the previous years there were some confusion there, so that's why the VCO exams have made it now. It's pretty direct. They won't make it that it has that many. It'll be pretty direct. Then when you change it, you're not going to get 2 different sequences. Or if it's a multiple choice, one of them works. Okay, so if they wanted this one, they would have wrote that as part of your multiple choice, and you might have got that. It means that you have to simplify it to get this to find the answer in the multiple choice. Okay, so both of them have different sequences. They have the same kind of transformation result, but they do start off differently. This is a translation, dilation, reflection, then translation. This one follows Dr. T. Answers are the same. Okay? So going back to this one, here we go. We now have answer is negative x plus 4, and depending on how you write your solution, if you stuck to just the first transformation you got, it would have been negative y minus 3 divided by 2, and then I think it was it plus 6 or minus 6? Plus 6? Plus 6. All right. So if you leave it like that, then your reading for the transformation would be very different. This would be a clear reflection, and then over here you're doing a translation before you do a dilation, before you do a reflection, before you do a translation again. Okay? If you simplify that down, so I don't know what the answers in the back, what they would have suggested. If they suggested something different, like Dr. T, it means that they've simplified this expression down. Okay? And that's what I mean. In the exams, you can get a version that looks like this, or you can get the simplified version, which follows Dr. T. Okay, and I think usually that kind of problem would be more likely to be a multiple choice question, so that examiners, when they mark, there's not such a variety that they have to read through. Okay, so they'll likely just stick to one, but that could really change. Okay, how do we feel? That last one was a bit nuts, eh? But you got the essence. 3D is to move from sequence to graph, also equation, and then 3e is equation 2 sequence. That's the idea. All right, I'm going to stop the video